Hi, I'm David and this is the Biology Classroom. This is a video about the Spearman's rank correlation coefficient. There are a few things that you have to know before we use the Spearman's rank correlation to solve a problem. Firstly, the calculated value may range from -1 to 1, where -1 shows a perfect negative correlation, 1 shows a perfect positive correlation, and 0 indicates no correlation. However, it measures only monotonic relationships that are not necessarily linear, unlike Pearson's correlation, which is used to assess linear relationships. Let me show you a simple example. In the graphs below, A shows that X and Y change together at a constant rate. In B, they also change together, but not in a linear pattern. When you analyze them by using Pearson's correlation, the value can show you that A is a more linear relationship than B, as the value is closer to 1. But when you use Spearman's rank correlation to analyze them, it might give you the same result, which indicates the positive correlations, but not the degree of the linear relationship. Spearman's rank correlation usually used to assess data points within samples that are independent of each other. For example, the relationship of percentage cover of two plant species in a place. Let's say an ecologist collected data from an area of wildflower meadow by using a quadrant. She would like to assess whether a correlation existed between two of the plant species, daisy and poppies, in that area. Spearman's rank correlation can be used for this evaluation. First of all, we have to identify the null hypothesis. We assume that there is no correlation between them. So the null hypothesis sounds like this. There is no correlation between the percentage cover of daisy and the percentage cover of poppies. Then, we need to rank the data. In Spearman's rank correlation, we use the ordinal data or the rank values for each variables rather than the raw data. So, what we have to do is assign ranks from lowest to highest for both variables. Let's look at the daisy first. The lowest value in the column is 0, so it will be given the rank of 1. The next smallest number will be given a 2, and so on. If there are tight scores, each of those will share the ranks and be given the average rank. In this column, quadrant 6, 7, and 8 are 2%. The ranks here should be 3, 4, and 5, so all of the quadrats got the average rank, which is 4. After all of the values are ranked, calculate the difference, D, between rank 1 and rank 2 for each row. Then, calculate D squared for each row and find the sum. Now, you can calculate Spearman's rank correlation, RS, by using the formula. N is the number of pair data in your calculation. In our example, we have 12 quadrats, so the number of pair data is 12. Based on the calculation, the RS value is -0.445. Since it is closer to -1, there might be a negative correlation between the two variables. However, in order to make a solid conclusion, we need to test the significance of this value. We will use the table of critical values of Spearman's rank correlation coefficient to do this. We usually use 95% of confidence level in a biostatistical test, so we will be looking at P equals to 0.05. The intersection of our N, 12 in this case, and P equals to 0.05 is the critical RS value. Then, we will compare the calculated RS value to the critical RS value. Bear in mind that when interpreting the table of critical values, the sign of our RS value is ignored. We will only use the value without the negative sign. If RS calculated is smaller than the critical RS, then the null hypothesis is accepted. If it is the opposite, then the null hypothesis is rejected. In our example, RS calculated is smaller than the critical RS, so the null hypothesis is accepted. There is no correlation between percentage cover of daisy and the percentage cover of poppies. Even though we have a RS value that shows a negative correlation between them, but the test of significance shows that this is not strong enough to indicate the correlation. If you enjoyed this video, don't forget to like, comment, and subscribe. You can also follow me on Facebook. Thank you and see you again soon.